module from this chapter, some application of trigonometry. We're doing a sum based on angle of elevation. Let's see the sum first. Let's read it. The sum says that the TV tower stands vertically on a bank of a canal. From a point on the other bank directly opposite to the tower, the angle of elevation of the top of the tower is 60 degree. From another point 20 meter away from this point on the line joining this point to the foot of the tower, the angle of elevation of the top of the tower is 30 degree. Find the height of the tower and the width of the canal. Now you would be thinking, it's so big a statement. How will you understand this? It's very easy. Don't worry. Simple, simple, simple. Don't worry. Very easy. Let's understand. It says a TV tower stands vertically on a bank of a canal. So there is a canal. You can see there's a small canal here, right? And there's a TV tower which is standing here. See, this is a TV tower which you can see, right? Right? And that is there on the bank of a canal, as you can see. Then they say from a point on the other bank. So the TV tower is on this side, right? This bank. From a point which is on the other bank. That means on the other bank, there's a point which you are taking here. So there's a TV tower and there's a point which you are considering on the other bank, right? Directly opposite to the tower. If you can see that is being highlighted there. Now this is a point which you have. From this point, the angle of elevation of the top of the tower. That means from here, an observer, there is an observer here. This observer is observing the top of the tower. And is making an angle of elevation. That means there is a line of sight which is made. And this line of sight is nothing but making an angle with the horizontal line there. And that angle is given as 60 degree. Remember, here the height of the observer is neglected because it is not given. So you are taking it as a point. Easy till now. You understood what you have drawn till now. Beautiful. Let's move ahead now. Now it says from another point. So we have to consider another point. From another point, 20 meter away from this point. So from this point, you have to take a point which is away from this 20 meter. On the line joining this point to the foot of the tower. That means from this to the foot of the tower on that particular line. Same line, you have to take a point which is 20 meter away. So you have to take a point backwards here, right? So we are taking that point here. That means in short that observer is now going to move. See, is going to move 20 meter backwards. See. Is moving, is moving, is moving, is moving. Yes, and he reaches a point which is 20 meter away from that particular point, right? And again, he is observing the top of the tower. And this time the angle of elevation is given as 30 degree. Hope so you have understood what you have drawn this in this sum till now. Wasn't that easy, right? Now what we need to find is, find the height of the tower. So our job is to find the height of the tower here and the width of the canal, right? And this is what you are ultimately supposed to draw. Correct? Now this is something which it will look like. Now we give the description here. We're going to write here. In this we say that AB represents the height of the tower and we take it to be H. Right? And we know that BC is nothing but it's the width of the canal which we need to find. That's the other thing which we need to find. What else do we have here? So we have written BC be the width of the canal and we take it as X. These are the two things. We need to find H as well as X. And we have two angles given to us. First of all, I've said whenever you have a sum like this, where you have two right angle triangles, observe. The most important thing is, you're going to consider each of those two right angle triangles. Apply a trigonometric ratio. But before that, remember the common side. Here the common side for both the right angle triangle is H. So that is very important, critical. Find that. You will get the other values very easily. So let's see now. You have been given that distance DC is given as 20 meter. That's the information which we have. Now consider the right angle triangle ABC. In this right angle triangle, find an acute angle. Do we have an acute angle there? Yes, that is angle C. Now for that angle C, what do we have? We have AB, which is the opposite side, and we have BC, which is the adjacent side. So we are talking about opposite side and adjacent side. So which ratio comes to your mind? Yes, that ratio is nothing but tan. So now we are going to use tan for that particular angle 60. So we write tan 60 is equal to AB upon BC. Now the value of tan 60 from the trigonometric table we know is nothing but it is root 3. So we substitute that value there. That is equal to AB is nothing but it is H, and the value of BC we have taken it as X. So we keep it as X in the denominator. I said important thing in this type of sum is get the value of that common side. That means here it is H. So find H. What is H? We say that H is equal to root 3x. We got that value. Remember, this is going to help us now in the next right angle triangle. So what is the other right angle triangle? Yes, it is triangle ABD. So in this right angle triangle, observe which is the acute angle we have here. Yes, we have that acute angle which is D. Now let's see, for this angle D, we have AB which is the opposite side, right? And we have the adjacent side here which is DB. Now observe adjacent side. So we are talking about opposite side and adjacent side. So which ratio are we talking about? Yes, again the ratio which you are going to use is nothing but tan, right? So we get tan of that angle, that is 30, is equal to AB upon BD, right? Now we have to just substitute the value. The value of tan 30 from the table, you remember how much is that? It is 1 upon root 3. We write tan 30 is 1 upon root 3, substitute that. The value of AB, what is that? It is nothing but H. We keep it as it is, that is H, upon the value of dB. Now look at the figure and tell me, students, what is dB? We know dB is nothing but DC plus BC. That means it is 20 plus X. So we substitute that value there. So, right, that is X plus 20. So now we can cross multiply. So we write H is equal to, that is X plus 20 is equal to root 3 into H. That is what we got here, right? But so now the left hand side remains as it is. X plus 20 is equal to, you know the value of H? Yes, we have already found it out. It is nothing but root 3x. We substitute that value, root 3x into root 3, which is there existing on the right hand side. Now when we solve the left hand side, it remains as it is, that is X plus 20. On the right hand side, it is root 3 into root 3. How much is that? Yes, it is 3x. So now you have an equation involving variable x. So we can find the value of x, solve it further. So we get 3x minus x, that is 2x is equal to 20. Hence we get the value of x as 10. You know what is x? X is nothing but 10. That means we got that width of the canal, right? One question is done. Just we now need to get the height of the tower. What is that? H. And that is what we have, because H is dependent on X. We got the value of X. Now we find H. So we write now H is equal to root 3x. That means it is root 3 into 10. And we know that the value of root 3 is 1.73. So we write there 10 into 1.73. We substitute that value, right? And when we multiply, the decimal moves one place to the right. So we have H is equal to 17.3. That means now we got the height of the tower. So now we can write the final answer. Therefore, the width of the canal is 10 meter and the height of the tower is 17.3 meter. A very, very beautiful sum, but a very important one.